welcome back to the channel. I'm excited. Today is my first introductory science video. I apologize about it being a week late. So lesson learned to be ahead a week for videos because my kiddo was sick last week when I was supposed to film. But today I want to start with something that I'm passionate about, and that's climate change. And I just really feel it's important that everyone have at least an introductory knowledge in terms of what it is and what causes climate change. Because we talk about climate change like it's this future issue, but it's really not. It's already here. We already see effects of this. And in general, it's a very abstract thing to wrap your head around. So oftentimes, in our day-to-day life, we see cause and effect happening right before our eyes. Climate change is a little bit different than that. So while we know that there are effects happening from climate change, it might not be such a direct thing that we can physically see. So scientists, of course, try to model how this will change our future and how we're seeing the effects right now, but it is really challenging. And so before beginning today, I do think it's really important to discuss the difference in weather versus climate, because we're not talking about weather change, we're talking about climate change. And I often hear people talk about climate in terms of weather they're experiencing, but they are different things. So weather refers to the current or short-term conditions at a particular location. So think about when you're opening your app to see what the temperature is today, if it's going to rain or not, right? Those are all weather conditions at your specific location. When we're talking about climate change, we're talking about long-term data or long-term weather patterns, generally over a period of 30 years or more, because it's much more meaningful to draw trends from long-term data, because weather can change very drastically, as I'm sure you know, day to day, based on just local factors at your location. So when we're talking climate change, we're talking long-term changes that scientists are seeing. All right, now moving into what even causes climate change. And in order to discuss this, we have to address greenhouse gases. So I actually think the best way to do this is to draw a diagram. All right, so here, of course, we have planet Earth. And I'm just going to depict the sun over here. So here is our sun. Now, energy that we receive from the sun is what we call shortwave energy or shortwave radiation. So we'll go over that in a later video. Okay, but I do want to represent energy coming from the sun here. Okay, so that is going to be our shortwave radiation. So I'm just going to call that SW radiation. Now, some of this radiation is immediately reflected back to space. So that can happen in our atmosphere or at the surface of the planet. Okay, so we're gonna just draw this to represent that energy being reflected back to space. However, some of that energy is absorbed, whether that be in the atmosphere or at the surface of the planet. So I'm just going to draw this to represent that absorption. Now, energy that's absorbed is then re-emitted by Earth as long wave or what we call heat energy. So this is going to represent our heat energy. Okay, now I want you to imagine that we have a blanket surrounding our planet. So this pink line just represents that imaginary blanket. Especially closer to the surface of the planet, we have molecules that act as this blanket to capture heat energy. So these molecules are what we call greenhouse gases. So they include things like carbon dioxide, methane, nitrous oxide, and even water vapor. So those are our greenhouse gases. So I'm going to call those GHG, greenhouse gases. These greenhouse gases are super effective at absorbing that outgoing heat energy. Even though they make up a very, very small percentage of our atmosphere in terms of total molecules, they're super important because they do absorb that heat energy. So they're naturally occurring and we actually need them to survive. So it's because of these molecules that our planet absorbs heat and we can support life on Earth as we know it today. So they are naturally occurring from things like wetlands, volcanic eruptions, the decomposition of organic material, all produce greenhouse gases naturally. So those would be found even if we were not here on the planet. However, humans increase the amount of greenhouse gases in our atmosphere. So ever since the Industrial Revolution, where we began to use fossil fuels, only coupled with population growth and the use of landfills, the livestock industry, the agricultural industry, all of these things are also contributing to increasing greenhouse gases in our atmosphere. This is something that you could actually show and do in a lab. So we know that greenhouse gases absorb heat energy. We know that all of these factors, the combustion of fossil fuels, livestock, all of these different ways which we contribute greenhouse gases do indeed contribute extra greenhouse gases. So it only makes sense that the more greenhouse gas molecules we have in our atmosphere, the more heat energy in turn will be absorbed. And you can imagine, considering that our planet is warm enough to support life as it is, with such a small fraction of greenhouse gases in our atmosphere, how easy it is to actually impact how much heat energy is being absorbed by those additional greenhouse gases. But ultimately, our planet is very, very complex. And I'm sure you know how difficult it is for forecasters to even predict the weather day to day. Therefore, it's incredibly challenging when you're talking about the planet as a whole and this excess energy to predict exactly what's going to happen in the future with climate change. But we are already seeing effects today that make perfect sense when you're talking about the Earth absorbing more heat energy. So things like sea level rise from the melting of sea ice, or things like more intense weather patterns, as well as things like increasing global temperatures. All of these things are impacts that we're currently seeing from climate change. But of course, in the future, we expect things to only become more severe. So I hope this provided some context in terms of, what is climate change, what is causing climate change. And if you have any questions, I will do my best to answer them. So please let me know in the comments. And I hope you learned something today. I plan in the future to start talking about the effects of climate change, as well as what a carbon footprint is. So those are all videos I hope to do in the future. But go ahead and click subscribe if you're interested in learning more about environmental science topics. And I hope you have a good one.